Now, let us talk about aggregations, which are really a staple of any sort of data analysis. And an aggregation is a function that takes any number of values and compresses them down to a single informative value. So I'm looking here at my usual characters table, but this is the version that I have in Google Sheets. And as you know, we have this level column, which contains the level of each character. And if I select this column in Google Sheets, you will see that in the bottom right corner, I can see here a number of aggregations on this column. And like I said, no matter how many values there are in the level columns, I can use aggregations to compress them to one value. And here you see some of the most important aggregations that you will work with. Sum, simply adding up all values together. The average, which is doing the sum and then dividing by the number of values. The minimum value, the maximum, the count, and the count numbers, which is the same here. So these are basically summaries of my column, and you can imagine in cases where you have thousands or millions of values, how useful these aggregations can be for you to understand your data. Now here's how I can get the exact same result in SQL. I simply need to use the functions that SQL provides for this purpose. So as you can see here, I'm asking for the sum, average, minimum, maximum, and count of the column level. And you can see the same results down here. Now, of course, I could also give names to this column. For example, I could take this one and call it max level. And in the result, I will get a more informative column name, and I can do the same for all columns. Now, of course, I can run aggregations on any columns that I want. For example, I could also get the maximum of experience and call this max experience. And I can also run aggregations on calculations that involve multiple columns as well as constants. So everything we've seen about applying arithmetic and logic in SQL also applies. Now, of course, looking at the characters table, we know that our columns have different data types, and the behavior of the aggregate functions also is sensitive to the data types of the columns. For example, let us look at the many text columns that we have, such as class. Now, clearly not all of the aggregate functions that we've seen will work on class, because how would you take the average of these values? It's not possible, right? However, there are some aggregate functions that also work on strings. So here's an example of aggregate functions that we can run on a string column such as class. First, we have count, which simply counts the total number of non-null values. And I will give you a bit more detail about the count functions soon. Then we have minimum and maximum. Now, the way that strings are ordered in SQL is something called lexicographic order, which is basically a fancy word for alphabetical order. And basically you can see here that for minimum, we get the text value that occurs earlier in alphabetical order, whereas warrior occurs last. And finally, here's an interesting one called string ag. And what this does is that this is a function that actually takes two arguments. The first argument, as usual, is the name of the column, and the second argument is a separator. And what this outputs is now a single string, a single piece of text, where all of the other pieces of text have been glued together and then separated by this character that we specified over here, which in our case is a comma. Now, if you go to the Google documentation, you will find an extensive list of all the aggregate functions that you can use in Google SQL. And this includes the ones that we've just seen, such as average or max, as well as a few others that we will not explore in detail here. So let us select one of them. such as average, and see what the description looks like. Now you can see that this function returns the average of all values that are not null, and don't worry about this expression in an aggregated group. For now, just think about this as meaning all the values that you provide to the function, all the values in the column. Now there is a bit about window functions, which we will see later. And here there are, in the caveat section, there are some interesting edge cases. For example, what happens if you use average on an empty group, or if all values are null, in that case it returns null, and so on. You could see what the function does when it finds these edge cases. And here is perhaps the most important section, which is supported argument types. And this tells you what type of columns you can use this aggregation function on. So you can see that you can use average on any numeric input type, right? Any column that contains some kind of number, and also on interval. An interval, we haven't examined it in detail, but this is actually a data type that specifies a certain span of time. So interval could express something like 2 hours or 4 days or 3 months. It is a quantity of time. And finally, in this table, returned data types, you can see what the average function will give you based on the data type that you insert. So if you insert an integer column, it will return to you a float column. And that makes sense because the average function involves a division, and that division will usually give you floating point values. But for any other of the allowed input types, such as numeric, bit numeric, and so on, and these are all data types which represent numbers in BigQuery, the average function, as you can see here, will preserve that data type. And finally, we have some examples. So whenever you need to use an aggregate function, that is, whenever you need to take many values, a sequence of multiple values, and compress them all down to one value, but you're not sure about which function to use or what the behavior of the function is, you can come to this page and look up the functions that interest you and then read the documentation to see how they work. Now here's an error that typically occurs when starting out with aggregations. So you might say, well, I want to get the name of each character and their level, but I also want to see the average of all levels, and because I want to compare those two values. I want to compare the level of my character with the average on all levels. So I can write a query that looks like this, right? Go to the fantasy characters table and then select name, level, and then average level. But as you can already see, this query is not functioning. It's giving me an error, and the error says that the select list expression references column name, which is neither grouped nor aggregated. So what does this actually mean? To show you what this means, I've gone back to my Google Sheets where I have the same data for my characters table, and I have copy-pasted our query over here. Now, what this query does, it takes the name column, so I will copy-paste it over here, and then it takes the level column, copy-paste this here as well, and then it computes the average over level. Now, I can easily compute this with sheet formula by writing equal, and then calling the function, which is actually called average. And then within the function, I can select all these values over here, and I get the average. Now, this is the result that SQL computes, but SQL is actually not able to return this result. And the reason is that there are 3 columns, but they have mismatching number of values. Specifically, these 2 columns have 15 values each, whereas this column has a single value. and SQL is not able to handle this mismatch. Because, as a rule, every SQL query needs to return a table. And a table is a series of columns where each column has the same number of values. If that constraint is not respected, you will get an error in SQL. And we will come back to this limitation when we examine advanced aggregation techniques. But for now, just remember that you can mix non-aggregated columns with other non-aggregated columns, such as name and level, and you can mix aggregated columns with aggregated columns, such as average level with sum level, for example. So I could simply do this, and I would be able to return this as a table because, as you can see, there are two columns. Both columns have a single row. The number of rows matches, and this is actually valid. But you might ask, can't I simply take this value over here and just copy it in every row, and until I make sure that average level has the same number of values as name and level, and so return a table and respect that constraint? Indeed, this is possible. You can totally do this, and then it would work, and then this whole table would become a single table, and you would be able to return this result. However, this requires the use of window functions, which is a feature that we will see in later lectures. But yes, it is totally possible, and it does solve the problem. Now, here's a special aggregation expression that you should know about because it is often used, which is the count star. And count star is simply counting the total number of rows in a table. And as you can see, if I say from fantasy characters select count star, I get the total count of rows in my results. And this is a common expression used across all SQL systems to figure out how many rows a table has. And of course, you can also combine it with filters with the where clause in order to get other types of measures. For example, I could say where is alive equals true, and then the count would become actually the count of characters who are alive in my data. So this is a universal way to count rows in SQL, although you should know that if you're simply interested in the total rows of a table and you are working with BigQuery, an easy and totally free way to do it is to go to the Details tab and look at the number of rows here. So this was all I wanted to tell you about simple aggregations for now. And last question is, why do we call them simple? Simple as opposed to what? I call them simple because the way we've seen them until now, the aggregations take all of the values of a column and simply return one summary value. For example, the sum aggregation will take all of the values of the level column and then return a single number, which is the sum of all levels. And more advanced aggregations involved grouping our data. For example, a question we might ask is, what is the average level for mages as opposed to the average level for archers and for hobbits and for warriors and so on? So now you're computing aggregations not over your whole data, but over groups that you find in your data. And we will see how to do that in the lecture on group by. But for now, you can already find out a lot of interesting stuff about your data by running simple aggregations.